So, we're going to talk a little bit more about agriculture and production. But first, we need to talk about how words matter. So, what we call things and what we name things has an effect on how we think about them. You might want to think about the terms pro choice or pro life, meaning different things, but they let somebody know what side of an issue we are standing on. For agriculture, some of the words we want to think about are conventional versus organic when we're talking about produce. So, my question to you is what's conventional about spraying chemicals on our fields? Okay. We had talked a little bit last week about carrying capacity and what that means. This week I've posted an essay by Aldo Leopold, and that illustrates carrying capacity in a much more poetic way. But what we're thinking about for this class in terms of agriculture and production is we've examined how agriculture was discovered or invented, so to speak, and we see that we've artificially extended the carrying capacity by growing things, but also by irrigation. So, bringing water to where there wasn't any before, and then using animal labor as well as other humans' labor to artificially increase our carrying capacity. And things stood that way for quite a long time until we discovered some other methods, and we're going to start talking about that. So, if we want to think about the word conventional versus organic, maybe chemical is a better word than conventional. So, we might think of chemical farming versus organic farming. Um, by the way, what do you think the effect on sales would be if we started calling things chemical farming versus organic farming or chemical versus conventional? Um, so, brief rundown on how plants work. You probably already know this, but the first law of thermodynamics tells us that energy is not created or destroyed. It can, however, be changed or altered. So, plants receive energy from the sun and convert it into plant mass. And plants also extract nutrients from the soil. So, one of the biggest challenges that farmers face is replacing those nutrients that are extracted by plant growth. Now, the big three are known as NPK: nitrogen, phosphorus, potassium. I don't know why one of them is called K instead of P. For millennia, though, agriculturists have known that animal droppings, so feces, guano, things like that, and bone contain nutrients that benefited the soil. In fact, so much that battlefields and graveyards and catacombs used to be robbed and the bones were taken for phosphorus. Now, nitrogen is plentiful in the air, but not in a form that plants can use. So, nitrogen fixing, which is a way to convert atmospheric nitrogen into a form that plants can use, was discovered at the beginning of the 20th century by Fritz Haber. I've posted a link to a Radiolab piece about Haber that's quite fascinating. As you'll discover, nitrogen is also a major component of explosives. So during World War II, new nitrogen plants were constructed for munitions, and by the war's end, they were producing over 730,000 tons of anhydrous ammonia, which is the form atmospheric nitrogen takes when it's converted, with a capacity of producing 1.6 million tons. After the war, what were we going to do with all this nitrogen production? Answer: turn it into fertilizer. We're going to see the same thinking again later, which is overproduction followed by dumping of product and then finding a market for that. So all of this nitrogen makes plants grow, but at a price. One of those prices is the dead zone in the Gulf of Mexico, which is nitrogen runoff from the Mississippi River Basin, makes an annual algal bloom which chokes off all oxygen, and no fish or plant life can survive. Um, we are achieving, well, achieving's the wrong word. We're finding dead zones of over 8,500 square miles. And I've posted a couple of articles about that you can take a look at. Also, with nitrogen fertilizer, it creates nitrous oxide. It's a greenhouse gas that's 300 times more potent than CO2. I've posted a couple links to the EPA's report on greenhouse gas emissions. And greenhouse gases are among the things responsible for climate change. So, what happens to agriculture when the Earth's average temperature increases? Well, for one, we might lengthen the growing season in regions that have a relatively cool spring and fall. Will certainly, it'll have adverse effects on crops in regions where the summer heat is already limiting production. Will increase soil evaporation rates, and as we're seeing now, increasing the chances of severe drought. So the IPCC, the Intergovernmental Panel on Climate Change, predicts that moderate climate change will likely increase yields of North American rain-fed agriculture, but with smaller increases and more variability than earlier estimates. Most studies project likely climate-related yield increases of 5 to 20% over the first decades of the century, with the overall positive effects of climate change persisting through much of the 21st century. Food production is projected to benefit from a warmer climate, but there's probably going to be strong regional effects. Some areas of North America suffering significant loss, some gaining. So, in other words, where it's already very hot, we might see decreased yields, and places where previously things were harder to grow, maybe it's going to become a little bit easier. Now, that all sounds good. However, with the increase in drought, the increase in storm activity, the increase of the rising of the sea level, this is overall not a good thing. Agriculture itself is probably responsible for an estimated 1/3 of climate change. Generally agreed, about 25% of CO2 emissions are produced by agricultural sources, mostly deforestation, which means cutting down large forests primarily to graze animals like cattle. Use of fossil fuel-based fertilizers, and the burning of biomass, so burning husks of corn and things like that. Most of the methane in the atmosphere comes from domestic animals, ruminants like cows, so cow farts, forest fires, wetland, rice cultivation, and waste products, and tillage and fertilizer. So tillage meaning plowing up the land and then fertilizing. That use accounts for about 70% of the nitrous oxide gases. According to the IPCC, the three main causes of the increase in greenhouse gases observed over the past 250 years have been fossil fuels, land use, and agriculture. We can also think about how fertilizer use helps with destruction of the soil, or helps with is probably the wrong way to put it. It begins the destruction of soil biodiversity by diminishing the role that the nitrogen-fixing bacteria have that are in the soil, and amplifying the role of everything that feeds on nitrogen. So feeders then speed up the decomposition of organic matter, and then as organic matter decreases, the physical structure of the soil changes. So there's less pore space and less sponge-like quality, so soils are less efficient at storing water and air. Then means we need more irrigation. Water leaches through the soil, draining away nutrients that no longer have an effective substrate to cling to. And then with less available oxygen, the growth of soil microbiology slows, and we have a really intricate ecosystem of biological exchanges in that soil that breaks down. Now, another thing that anhydrous ammonia, which is that nitrogen that's fixed from the atmosphere, is also a major ingredient in, is the production of methamphetamine. So where there's fertilizer, there are usually meth labs, which is one of the reasons that meth has such a strong hold on rural communities. I've posted a link to a look at the book Methland, which it's a pretty interesting read if you have not checked it out. If we're talking about eroded topsoil or lost soil fertility, on average it takes about 5.5 gallons of fossil energy to restore a year's worth of lost fertility to an acre of eroded land. As far back as 1997, we burned through more than 400 years worth of ancient fossilized productivity, most of it from someplace else, meaning we've imported oil. So this is kind of all the bad things about fertilizer. Now, obviously, the good parts is that fertilizer helps increase yield. And we've used fertilizer in one form or another for a long, long time. Organic farmers use fertilizer. Now, usually that's in the form of some type of manure or bone meal or fish meal, things like that. The issue really is fertilizer that's based on fossil fuels, because those are starting to run out. In future classes, we will talk about the concept of peak oil. For now, just let that phrase sink into your head a little bit. If you'd like, go ahead and do a little bit of research on that, but we will be talking about that further along. So, talking about organic farming. Now, many of you may already know what we're talking about, but I think it'll pay to give a little bit more definition. So, it's referring to the way that agricultural products, both food and fiber, are grown and processed. It's based on a system of farming that maintains, replenishes soil fertility without the use of toxic and persistent pesticides and fertilizers. Organic foods generally are minimally processed without artificial ingredients, preservatives, or irradiation. Now, this has changed a little bit. 30 years ago, a woman named Joan Gussow, who was a nutritionist at Columbia, had warned that unless we were kind of on our toes, we would see the rise of what she called the organic Twinkie. And I believe she was right. That's exactly where we are today. We do have a lot of organic products on the marketplace, but they may not necessarily be what most folks or many folks in the organic movement had in mind when they were originally discussing and promoting organic food. Since the USDA's involvement, we have some rules and regulations that have been laid down. One is if something's called 100% organic, means that can only contain organic ingredients, no antibiotics, hormones, genetic engineering, radiation, or synthetic particles. That can display the USDA organic logo and or the specific certifying agent's logo. Now that's 100% organic. If something says merely organic, that means it contains 95% organic ingredients, with the balance coming from ingredients on the approved national list. Now, these can also display that organic logo. We then get to made with organic ingredients, which must be made with at least 70% organic ingredients, 3 of which must be listed on the package, and the balance must be on the national list. These products can display a certifier's logo, but not the USDA logo. Now we have large corporations which can make organic granola bars, or the organic Twinkie, if you will. And organics used to mean largely local, small, and family-owned operations. It can now mean food grown half the country away or in other countries, and by large corporate-owned farms that use highly mechanized methods and distribute through centralized large transportation systems, which is not really the organic model that most of the people were promoting in the 1970s and 1980s. The good news, I guess, is that even large organic were applying fewer pesticides, and hopefully that's better for our planet overall. We still have all of the other issues associated with large-scale agriculture, though. Among those, monocropping, which you're going to be discussing in the discussion forums later this week. So let's start thinking about the words we use and what effect they have on the discussions that we're having. Think about what our own concept of organic agriculture might be, what our own concept of conventional or chemical agriculture might be, and try to see how that fits in or doesn't fit in with the government's concept of organic agriculture or chemical agriculture. Um, Many of us may know farmers or producers who are essentially organic farmers, but who aren't certified because they don't want to incur the expense of the paperwork involved or the fees involved with certification, and yet they're doing all of the things involved with organic agriculture. Now, we're not going to debate at this point whether organic agriculture is better nutritionally, or any of those kinds of issues. Really, at this point, we're only kind of taking a look at pesticide use, because that's really a lot of what the current standards have boiled down to. Now, if we want to talk about sustainable agriculture, which we will next week, that's an entirely different conversation. So for now, check out those links and go participate in the discussion forums.